Hi John, how's it going? I texted you earlier, so what we're going to do is if you want to ask me any questions tomorrow about the chapter 10 stuff, you can. And then after that, we're pretty much moving right along to chapter 11 right now. So I need you to take that test and that quiz, but I don't want you to do it if you don't feel comfortable yet. So ask me questions first and then take it, and go really slow when you do it, okay? But right now, this is the intro to chapter 11, which is trig graphs, and unfortunately I don't have the notes. Somehow it didn't get saved, so I'm gonna have to do this myself, so it might take a little bit longer, but bear with me. So this is trig graphs chapter 11. Okay, alright, so what we're gonna do is we're gonna use the unit circle that you have in front of you to create values of y is equal to sine of x at increments of pi over 4. So what is pi over 4? Pi over 4 is like 45 degrees, but this is in terms of radians. So what we're going to do is we're going to take a look at your plate. We're going to figure out those exact values for sine of x every pi over 4, and we're going to make a table, and then we're going to graph it to see what it looks like, okay? So let me make a table over here really quick for us. And it's kind of going to be a little bit weird counting in terms of radians, but it's something that I'm sure that you will get used to. Okay, so up here we're going to have our x values, and then down here we're going to have our sine of x. We're going to go through and do this for the other functions as well, so that you can see what those pictures look like. So when I mean by counting by pi over 4 or 45 degrees, we're going to go 0, pi over 4, 2 pi over 4, which actually reduces 2 over 4 is really 1/2, so this is going to be pi over 2. So that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which reduces down to 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is just 2 pi. So that's what I mean by counting in increments of pi over 4. Those are 45 degrees, each of them counting through in radians. Okay, so let me just make this a little bit neater. And I do want you to be taking notes on this. So we are going to go through your unit circle and figure out all of these values. So I want you to have your unit circle out in front of you and doing it with me. So when x is equal to 0, sine of x is also equal to 0, and x is equal to pi over 4, or at 45 degrees, sine is radical 2 over 2, at 90 degrees, or pi over 2, sine is equal to 1, at 3 pi over 4, which is 135 degrees, it's again a positive radical 2 over 2. At pi, or at 180 degrees, sine is 0. 5 pi over 4, now we're into the third quadrant, so that's a negative radical 2 over 2. 3 pi over 2, that's 270 degrees, we're at a negative 1. 7 pi over 4, that is in the fourth quadrant, so again we have a negative radical 2 over 2. And then at 2 pi, or 360 degrees, we're at 0 again. Okay, so all of those values were really the cousins of 45 degrees all the way around the unit circle. Okay, so the next thing that I want to do is actually graph those functions, or graph those values on a chart. So you know what I told you earlier, or in the one of the last videos that I made you, was that the domain, or the x values of trig functions, so sine, cosine, tangent, the x values go on towards positive infinity and negative infinity. So what we do is we call it all real numbers. The y values, or the range, however, is between -1 and +1. So you're going to see that when we make our chart. Now, Miss Tompkins would yell at me because we need arrows on all of our axes. We need to label things. So this is y and this is x. And then what we're going to do is go through, and this is going to be our +1. This is going to be our -1. Remember that our function is not going to go anywhere else but in between +1 and -1. And then I'm just going to go through and label all of these. So we have pi/4, because that's 0 right there. Pi/4, pi/2. And you're going to start out with your homework by labeling every single one of these, and then once we go on you can label them by 90 degrees, so 0, pi/2, pi, 3 pi/2, and 2 pi. But when we're starting out, I want you to label all of these. Pi, 5 pi/4, and the reason why we're doing this is to see the exact values at each of these increments so that you can get an idea of what the picture of the function looks like without me just like telling you and showing you what it is without you believing me. So that's the whole reason for us doing this. And I'm sorry it's taking a little bit longer because it's hard to write with this. 7 pi/4 and 2 pi. Now, some of your homework questions that you're going to do are going to ask you to graph between -2 pi and +2 pi, or -pi and +pi. We don't ever want to graph between negative something and positive something. Miss Tompkins always wanted you to graph between 0 and 2 pi. So if the question is asking you to do that, just kind of ignore that, okay? You're going to always graph between 0 and +2 pi. Now, before we start out, let's just get an idea of what the decimal of radical 2/2 is so that we have a better idea of what we're graphing. So on my calculator, radical 2 divided by 2, that's about 0.7. Alright, so that'll give me a better idea of what I'm graphing. Alright, so let's make this graph blue. Why not? Okay, so when x is equal to 0, sine is equal to 0. So it's going to go right here. At pi/4, sine is radical 2/2, or 0.7, so we're like about here. At 90 degrees, sine is all the way up here at +1. That's as high as it's going to go. At 3 pi/4, it's back down to 0.7, or radical 2/2. At pi, we hit 0. 5 pi/4, we're at negative radical 2/2, so negative 0.7, which is down here. At 3 pi/2, or 270, we are at -1. 7 pi/4, we're at -0.7 again, and then 2 pi, we hit a 0. Now I'm going to try to do this as neatly as possible. I'm really sorry about this whole mouse thing, but your sine curve should be very neat. It should flow nicely. There we go. You know what? That wasn't too bad. I'm actually pretty proud of that. Okay, so that is exactly what the graph y is equal to sine of x looks like. Okay? Y is equal to the sine of x. So, y is equal to sine of x. If you take a look, so it has a couple of characteristics about it that help us remember it. It starts at 0. Cosine is not going to start at 0. It goes up the hill first, and then it goes down the valley, and then it ends at 0 again. So this is exactly what the sine curve looks like. Now, if you break it up into its quadrants, so the quadrants that we have are between 0 and 90, so between 0 and pi/2, which is right here. So that's the first quadrant right in here. Between pi/2 and pi, or between 90 and 180, that's the second quadrant. Third quadrant is between 180 and 270. And then the third quadrant is between 270 and 360. So that is what they're asking you to do. If the question on a test says break it up into quadrants, and then sometimes they even want you to label it, so you go through with your Roman numerals 1, 2, 3, and 4. So what do you notice if you take a look at this graph? You see how that first part is half of a circle, or not half of a circle. Right here in the first quadrant, that's a quarter of a circle. Third quadrant, it's another quarter of a circle. Fourth quadrant, it's another quarter of a circle, and so is the fourth. So if we took all of those pieces and put it all together, we would form the unit circle. Okay, so it's just that we kind of took that unit circle and broke it apart and kind of stretched it along this whole x-axis instead of it being condensed together. So it's still the case that your range or your y values are between +1 and -1, and your domain or your x's can go on and on forever in either direction, so that I can extend that x-axis in any direction. Okay, so this is what the sine curve looks like, and then let's just take a couple of notes really fast about how to remember this. So the sine curve, and I want you to be writing this down. Whoops. Sine curve. Starts at 0, ends at 0, goes through 0, halfway between. Okay, so that's what we're going to use to remember how to graph this. Okay, and you're going to hear me repeat that a lot. And the reason why is because if I just have those notes written out for me, or if I just remember that, this is how easy that I can graph this. Watch. I'm just going to make an axis really quick for you. And if someone asked me to graph the sine curve for homework, which is what you're going to have to do, I would just go through with my pen and I would say, okay, I'm going to go between 0 and 2 pi. So there's 2 pi. Pi is right in between that. And then we have pi over 2, which is 90. And 3 pi over 2 right here, which is 270. Okay, so if I have that in my head, and I want to graph y is equal to sine of x, if I have those notes in my head, this is going to be so easy. Watch. So the sine curve starts at 0, so I'm going to put my 0 right here. It ends at 0, so I'm going to put my 0 right here. Goes through 0 halfway between. Okay, and then in between the first two zeros we reach its max. So in between these first two zeros we reach its max. In between the second two zeros we reach its minimum of -1, and then you just connect the dots. Hopefully a little bit more smoothly than I did. But you see how we only really need those 5 points, and we can make that sine curve really quickly. So sine starts at 0, ends at 0, goes through 0 in the middle. Between these first two zeros we're going to reach its max. Between the second two zeros we're going to reach its min. So it's going up the hill and then down the valley and then it ends. Okay, so that's how quick and easy it is to graph the sine curve. Okay? Now if I were to graph the sine curve between -2 pi and +2 pi, it would just kind of extend. It would keep going. It's a continuous curve, so it's not like it's going to just stop right there. It's going to keep going down, and then it'll go up again and down and up. But I'm not going to do that for you. I'm not going to waste your time because I think that you can figure that out. Let's see what else Miss Tompkins has written out here. She has, these are part of the notes, that there is one cycle of the sine curve in every 2 pi radians. There's one cycle of the sine curve in every 2 pi radians. Okay? That means that every time on a curve you see between 0 and 2 pi, that's one full cycle. Okay, so this is what the full cycle of the sine curve looks like. Alright, so we're starting at 0, ending at 0, going through 0 in the middle, in between it reaches its max, in between it reaches its min, and then it's just going to keep on going. So if you went between 0 and 4 pi, you would see 2 full curves of the sine circle. Okay? And I'm going to stop right here and then come back.